Hello there. I'm going to talk about our project proposal. The topic is concurrent computing in MATLAB and its application in biomedical image processing. As we know, MATLAB provides a handy platform for biomedical image processing with the powerful image processing toolbox. But there are several challenges. The data size may be large, and there might be lots of computational operations, and we may also have lots of parameters such as different threshold and different connectivity types. And understandably, there would be lots of simulation running on a single image. That's why we want to make our MATLAB program more efficient. And concurrent computing is a good way to significantly improve the performance. So in this project, we will focus on this area. Now, I want to mention some related works. There are mainly two approaches for MATLAB acceleration. One is the code optimization, and the other one is the low-level acceleration. For the code optimization, it always means vectorizing and pre-allocating memory space for the variables at the beginning, and as it shows the quality of the code. It's a good habit for us to writing codes in that way. But if we are expecting more improvement, we have to use some low-level acceleration techniques. Concurrent computing is one of them. And we are trying to employ several workers dependently or independently in MATLAB to run our program concurrently. Here you can see our methods. We have lots of input images, which are quite large. Um, and, and we will do some system study first. We, we will set up different platforms, Windows, Linux, and Mac, and we also have the CRC server. And we will use two different parallelism schemes. One is the multi-threaded parallelism, and the other one is the explicit parallelism. And during the experiment, we will try different threads to see how much improvement we can get. Basically, we have two stages. First one is to test the benchmarks to get some premier sense about the parallel program. And the second stage is to decompose our own algorithm to get some parallel version and to see how much it will benefit in our own research. So at last, we will do some program analysis to see the result. Here you can see performance is the main evaluation metrics. We will compare the original result with two different parallel schemes, which I just mentioned. And through the figure, you can see some sort of our expectation. With more threads are employed, the running time will be improved quite much. But it's not necessarily linear. At the beginning, we can expect much improvement, but at some point, the program is almost fully using the hardware resources, so there might not so much improvement in just here. Besides that, we will also compare the parallel we will also running the parallel algorithm in different platforms with same operating system but different hardware configuration, and the platforms with same hardware configurations but different operating system. So by doing this, we can have more sense about the improvement, or we can have more sense about the parallelization. Yes. Okay, thank you. That's all for today's presentation. Thank you for your time.